Hey guys, hope all's going good. Um, Hopefully the first couple weeks have gone okay and you've kind of settled into routine. Things are getting a little more normal, hopefully. Um, but before we go on to 7.3, I wanted to take a week to review factoring. Now, it doesn't matter if you're going on to pre-calc or if you're going on to college algebra. Factoring may just be that one thing that holds you back. I know when I went to college and I got differential equations, my biggest problem in differential equations wasn't differential equations, it was remembering how to fully factor polynomials. I mean, it'll plague you if you don't know factoring. I know for those of you who had me first semester, I said it a million times. You're probably rolling your eyes about now saying, yeah, Miss Davis, we know. But anyways, you've got to know how to factor. So I set up a video. I'm going to go over each of the way we factor, and then we're going to spend a week on a worksheet that I will post on Google Classroom, and you'll work through that. So first thing is by GCF, greatest common factor. This should be the easiest way. All you're going to do is look at each of the terms of the polynomial, and you're going to see what can you pull out of everything. Okay, well, I noticed that 32 and 42 are both even numbers, so I can pull out a 2. I noticed that the 42 has an x to the 8th, 32 has an x to the 7th, so I can pull out x to the 7th from either one. So if I pull out a 2 from the number and an x to the 7th, I'm left with, well, 42 divided by 2 is 21. X to the 8th divided by x to the 7th is just x, minus, well, 32 divided by 2 is 16. X to the 7th divided by x to the 7th is just 1. So this would be my final answer. Okay, before you do anything with any type of factoring, first look to see, can you pull out a GCF? Always look for a GCF. All right, quadratic function with 3 terms. Guys, there's a million ways to do these. There's about 5 different ways I know of that just different people within Andover Central High School teach this. So if I do it a different way than you and your way works and you understand your way, please do it that way. So we want to factor 12x squared minus 26x minus 10. Now, when I'm looking at this, first thing I want to do is I want to pull out a GCF, just like before. Well, I notice that I can pull a 2 out of the 12, the 26, and the 10. Okay, so I'm going to pull out a 2. Now, this 10 at the end does not have an x, so I can't pull out a variable. So I think a 2 is all I can pull out. So 12 divided by 2 is 6x squared minus 13x minus 5. Yes. All right. So now I want to look at what's here in parentheses. This is just a normal quadratic function with 3 terms. So I want to ask myself, I want 2 numbers that multiply to a times c and add to b. Okay, remember your 6 is your a, your negative 13 is your b, and your negative 5 is your c. So you have 2 numbers that multiply to a times c. So a is 6, c is negative 5. So you have 2 numbers that multiply to negative 6 times negative 5 is negative 30. 2 numbers that multiply to negative 30, but they have to add to b, which is negative 13. Don't drop those minus signs or negatives. Well, let me think. Will that just be 15 and 2, right? Negative 15 and positive 2. So negative 15 and positive 2. All right, so what that means is I'm going to take this now and I'm going to rewrite it a little bit. So 2 still out front, 6x squared minus, I'm going to change this b to these 2 numbers. So minus 15x plus 2x minus 5. Notice this here and this here are the same thing. The only difference is I wrote this 13x. This negative 13x is minus 15x plus 2x. Same thing. All right, so when I get to here, now I can put it in the box. Okay, so box it out. So I want each of my terms. So here's my 6x squared, my negative 15x, my positive 2x, and my negative 5. Okay, so I just start with the first column always. That's just a habit. So I look at these two numbers here and I say, okay, what's my common factor of 6x squared and 2x? Well, I can pull a 2 out and I can pull an x out. And after I get that first number on the outside, then I look at this as an area model. Okay, so I say, well, this has an area of 6x squared, and if this side is 2x, this side must be 3x, because 2x times 3x is 6x squared. And then the same thing over here. I look at this as an area model. If this is negative 15x on the inside, well, this is 3x, so this has to be 3x. So that means I'd have to multiply negative 5 times 3x to get negative 15x. Going down, if this is 2x, this is 2x, well, this has to be 1. And then if I did everything right, my negative 5 times 1 is negative 5, which it is. So what I just did is I found my factors. This is one of my factors. This is another one. So I'm going to rewrite this. My 2 still stays here. After I pull out a GCF, nothing happens to it except don't drop it. And then I'm left with 2x minus 5 and 3x plus 1. This is my answer. All right, difference of squares. We have this formula here. We did this a lot in class. By the way, guys, if you're struggling and you still have first semester's notes, go back to 4.4, I believe, which is where we did a lot of these factoring. All right, difference of squares. A squared minus b squared equals a minus b times a plus b. All right, so let's do an example. First thing I always want to do is I want to pull out a GCF. Well, 81 and 49, they don't have any common factors, but I can pull out an x from both sides. So x, I'm left with 81x to the 4th minus 49. All right, some of you are looking at this thinking, how is this the difference of squares? All right, well, isn't this the same as, just what's in parentheses, as 9x squared minus 7 squared. 9x squared, in parentheses squared, is 81x to the 4th. 7 squared is 49. So yes, this is a difference of squares. So 9x squared is my A, 7 is my B. Okay, so x times a squared minus b squared, so it's just a minus b, a plus b. Well, my a is 9x squared minus b is my 7 times 9x squared plus 7. This is my final answer. Always look in parentheses to see if you can break that down a little more and factor it out a little bit more. This time you cannot, so that would be my final answer. All right, difference of cubes and sum of cubes. Okay, a cubed minus b cubed and then a cubed plus b cubed. Let me go back a little bit. I probably should have said this and I didn't, so I'm going to go back and say it. There is no sum of 2 squares. So if you were to have like 81x to the 4th, if this was a plus 49, there's nothing you can do with that. It has to be a minus sign. Sorry, I should have said that when I did that. All right, difference of 2 cubes. Same thing, guys. The first step is always the same. Let's pull out a GCF. Well, here, 16 and 54, I can pull out a 2 from both of those, and I can pull out an x squared from both of those. And when I do, I'm left with 8x to the 3rd plus 27, and that's it. All right, so notice this is sum of cubes. we have a plus here. And you're saying, how is it the sum of cubes? Well, what's in parentheses here is 2x cubed plus 3 cubed. 2x cubed, remember, is 2 to the third times x to the third. 2 to the third is 8. X to the third, 3 to the cubed is 27, which means this would be my A, this would be my B. So I have the sum, so I would use this formula. Now, remember, don't drop your GCF, it stays here. We just don't have to do anything with it. So, A plus B, well, our A is 2x, plus our B is 3, times A squared, so 2x squared is 2 squared times x squared, which is just 4x squared. So A squared is 4x squared minus A times B, so 3 times 2x is 6x, plus B squared, so 3 squared is 9. Well, this doesn't factor any. No, so that's it. This is it. This is our final answer. All right, factor by grouping. Okay, you factor by grouping when you have 4 terms, okay? And what you want to do is you want to group 2 terms and then pull out a GCF. And what you should have in a perfect world is a number or variable or whatever that you can pull out of both. So I'm just going to factor this and this, okay? And I just have to rewrite it in parentheses because that's the way my brain knows that I have to separate it. So I'm going to rewrite this as x to the third plus 5x squared plus negative 4x minus 20. Okay, this and this are the same. I just rewrote it. All right, so now I'm going to look at this first. And I see that I can pull out an x squared. And when I do, I'm left with x plus 5. And then I'm going to look at this, and I'm going to say, okay, well, I can pull out a negative 4, and I'm left with x plus 5. This is exactly where I want to be, because notice I have an x plus 5 here. So then what I can do is I can pull out an x plus 5 from both, and what I'm left with is an x squared and a minus 4. All right, now I'm not done yet, because if I look at this, let me change colors here. If I look at this, this is the difference of squares. Okay, so my x plus 5 doesn't change. This becomes a minus b, a plus b. So my b is 2, my a is x, so this is x minus 2, x plus 2. This here is my final answer. All right, one more, polynomials in quadratic form. All right, so let's look to see if we have a GCF. Each of these are divisible by 3, so I can pull out a 3. Oops, guys, make this an x, make this an x. All the variables should be the same, my apologies. So pull out a 3 and we can pull out an x squared. And when we do, I'm left with x to the 6th plus 5x cubed plus 9. All right, now when I look at this, what's in parentheses here, I notice that I have a power And then this power is half of the first, and this is just a power of 1. So what I can do is I can treat it just like a quadratic function. And I could say, well, this would be 2 numbers that multiply to 1 times 9 and add to 5 is 3 and 2. Oh, I see what I did. Stupid me, guys. 18 divided by 3 is not 9. 18 divided by 2 is 9. This should be a 6. Oh, come on. This should be a 6. That makes better sense. My bad. All right, so 2 numbers that multiply to 1 times 6 and add to 5 would be 3 and 2. All right, so this would be x cubed plus 3, x cubed plus 2, and this would be your answer. Okay, for those of you who didn't like that, I know I did it another way that a lot of you liked. If that made sense to you, go away and don't watch this. So from here, I have 3x squared plus, times x to the 6th plus 5x cubed plus 6. And what we did in my class is I said, that plus shouldn't be there, is I said, all right, well, let's do substitution. Okay, let's let u equals x cubed. Okay, because when it does, if I substitute u in for x to the 3rd, I get 3x squared times, well, this is now u squared plus 5u plus 6. Okay, and now you can look at this and say, oh yeah, this is just like a normal quadratic function. 2 numbers that multiply to 6 and add to 5 is 3 and 2. So 3x cubed times u plus 3, u plus 2. Now, the only thing we have left to do from here is let's substitute this x cubed in for u and this x cubed in for u. So I have 3x, and this was a squared, not a cubed. 3x squared times x cubed plus 3 and x cubed plus 2. Notice, same thing, you could do it either way you want. The right has a little more steps, or an extra step if you will, but if that's what it takes for you to remember it, then do it. Let me know if you have any questions. Homework is on. No, homework is not on Big Ideas. There is a worksheet. Go through and do that entire worksheet, and I will talk to you guys later.